Good morning students. What are seen in the previous session ma? In the previous session I explained what is couple, what is principle of moments and what is how to define the center of gravity and then how to calculate the angle in a bending of cyclist position. That will be all are discussed in the previous session. In the today's session I will explain moment of inertia. Let us enter these topics. First you should know about what is inertia. What is inertia ma? Inertia means inability of a body to change their state of rest or in motion without applying the force. So with applying the force that the object it will be moving, okay, but without applying the force that the object cannot change their position of rest and then movement, okay. So that will be called as inertia. Inertia mostly is denoted to explain the mass of the object in a translation motion. So one object will be moving in a linear motion, that the object mass it will be considered as inertia, because mass it will be in a rest position. One object will be having the mass is in the rest position, that's the position it will be called as inertia. So inability of a body. Good morning students. What was learned in the previous session ma? In the previous session I explained what is couple, what is principle of moments, how to define center of gravity, how to calculate the direction of bending of cyclist one person by a person in on a road, or how to calculate the angle, and then how to calculate the torque it will be acting on the bending of cyclists one person on a road. That all are discussed in the previous session. In the today's session I will explain moment of inertia. What is mean by moment of inertia? So let us enter this topic. First you should know about what is inertia. What is meant by inertia ma? Inertia is nothing but inability of a body to change their state of rest or in motion by applying a force. So one force it will be applied on a body, that the body it will be moved. Without applying the force, that the body does not change their position of rest or in motion. Okay, so that will be called as inertia. Inertia means inability of a body to change their state of rest or in motion by applying force. So, moment of inertia, in the linear motion one object will be moving one point to another point, definitely it will be having weight. So that the mass not a weight, that the object will be definitely having mass, that the mass it will be called as inertia. But in the rotation motion, one object will be moving in a rotation motion, that the object it will be having a mass, that the mass it will be considered as moment of inertia, because the body it will be moving in a rotation motion, that's the rotation motion it will be called as moment of inertia. So movement of mass of one object in a rotation motion it will be called as moment of inertia. So simply it will be mentioned, one object will be moving in a translation motion, that the object mass it will be considered as inertia, but that the object it will be moving in a rotation motion, that the object it will be having mass, that mass it will be considered as moment of inertia. Just as nothing but movement of inertia it will be called as moment of inertia. Okay, so first moment of inertia is nothing but is a invariable quantity. Inertia just like that doesn't change without applying the force. So that's the way only. So not an invariable quantity. Moment of inertia is a invariable quantity, not variable quantity, but does not depend upon the mass of the body. Does not depend upon the mass of the body means it will be having a mass, but that the body will be having, some body will be having the huge size of mass, some body will be having the little bit mass. So that mass is not to be considered to movement of one thing. So does not depend upon the mass of the body, just it will be only denoted that the object does not move without applying the force, that only it will be considered. Okay, then moment of inertia, how to mention the moment of inertia? Moment of inertia normally it will be gives the I is equal to mr square is the formula for moment of inertia. So mass of the body and then distance. The particles in a rigid body it will be moving. So one distance between the first particle to second particle in the rigid body, that the rigid body will be in a rotation motion. That's the moment of inertia. I is equal to m into r square. R is the distance between the molecules in the rigid body. So I is equal to mr square, and we want to calculate the dI value. dI means simple simple moment of inertia. Moment of inertia will be acting in a single body, that it will be denoted as di. Di is equal to dm into r square. We want to calculate I. So moment of inertia I is equal to integral of di. Okay, so is equal to integral of dm into r square. Integral of dm into r square, so integral of r square into dm. So di is equal to dm into r square. So r square into dm. Okay, this is the formula for moment of inertia. I is equal to integral of r square into dm. Okay, clear? This is the formula for moment of inertia. Then what is the unit of SI unit of moment of inertia? Kilogram meter square, because mass unit is kilogram. Okay, mass unit is kilogram and radius is meter square. So kilogram meter square is the unit of moment of inertia, and then dimension formula for moment of inertia ml square. M is kilogram, mass value is capital M, and distance is L, so ml square. Ml square is the dimension formula for moment of inertia. So I is equal to mr square, kilogram meter square. Clear? So this is the moment of inertia. So then how to calculate the moment of inertia in the various size of object? So we can consider a rod, a ring and disc. So first we can consider rod or uniform rod. We can take the uniform rod, that the uniform moment of inertia in the uniform rod we want to calculate. Okay, so that is the uniform rod as having the length is small l. Okay, and the center of gravity will be acting as a center, and the moment of inertia, that the center it will be create the rotation motion, so that the point it will be considered as moment of inertia. The length is in the two sides of the rod is L by 2 and L by 2. Okay, we want to calculate moment of inertia di is equal to dm into x square. So dm into x square, and we want to calculate dm. So this is di is equal to, actually I is equal to mr square. This is the formula. Okay, I is equal to mr square is the formula, but we want to calculate di. Differentiation of I is equal to small moment of inertia is equal to, we had considered the small mass because this is the, we consider the little bit mass in the full rod. Okay, so that is a small mass dm, and the distance between the center of gravity to this mass is x. Okay, this is x and then x square. So distance between the center of gravity to that the mass, so dm into x square. Then we want to calculate dm value. Dm is infinitesimally small mass, so dm is equal to lambda into dx. How to derive that? Dm is a small mass, so that the mass is having some density, linear mass density. The linear scale இந்த இடத்துல அதோட density என்ன into that the distance between the from the center of gravity. So dm, small dm is equal to linear mass density. Lambda is linear mass density. Lambda is linear mass density. Linear mass density. Linear mass density means scale is very linear as a straight line. This it will be having some mass. The mass it will be dense in the particular point, that it will be called as linear mass density. So lambda into dx is equal to lambda. How will you calculate? Linear mass density is equal to mass per unit length. ஒரு யூனிட் லென்த்தில் எவ்வளோ மாஸ் இருக்குது? ஸோ மாஸ் பர் யூனிட் லென்த் இட் வில் பி கால்ட் அஸ் லீனியர் மாஸ் டென்சிட்டி. ஸோ m by l into dx, and then we want to calculate moment of inertia of the rod. This is the rod. We want to calculate the moment of inertia. So moment of inertia I is equal to integral of di. So we want I, so we taking the integration of di. So integrating of di is equal to, substitute the di value as a having dm. So first dm value we want to put, so m by l into dx. Okay, this is the dm value, m by l into dx into x square. So di is equal to integral of m by l into dx into x square. Okay, this is the linear mass density value, sorry, in the dm value and the x value. Clear ma? So next we want to calculate, we have to take m by l it's outside. So m by l integrating minus l by 2 to l by 2 x square into dx. Integral of minus l by 2 to l by 2 x square into dx. Okay, now we want to calculate x square into dx. Already you know that integral of x into dx, x power n into dx means x power n plus 1 by n plus 1. Okay. So this term it will be having x square. X square means x power 2 plus 1 by 2 plus 1. That it will be equal to x cube by 3. Okay. 2 plus 1 is 3. So x cube by 3. So integral of x square into dx is x cube by 3. So substitute that value x cube by 3 and then limit is minus L by 2 to L by 2 because the length is 2 length is there. One is the left side of the origin, so minus L by 2. Another one is the right side of the origin, that will be taken as positive L by 2. So minus L by 2 to plus L by 2 into x square into dx. Okay. So m by L it will be taking the outside. So m by L, then x square, integral of x square is x cube by 3 minus L by 2 L by 2. Okay. Then next, so we applying the limit value. So m by L at the outside, taking at the outside, x cube by 3. So L by 2 the whole cube by 3, L by 2 the whole cube by 3 minus of minus L by 2 by 3 the whole cube. Okay. So first applying the upper limit minus applying the lower limit. Okay. Then m by L, then L by 2. So L cube, 2 cube that is 8 by 3 minus L cube minus L cube by 8 by 3. Okay. Then m by L, then L cube by 24 minus into minus plus L cube by 24. So 2 times L cube by 24 plus L cube by 24. So 2 terms is there, 2 times is there. So m by L into 2 into L cube by 24. Okay. Then 2, 1 2s are 2, 12 2s are 24. Then L cancel. So m into L square by 12. So this term it will be mentioned m 1 by 12 into m L square. So this is the moment of inertia of a uniform rod. Taking the rod it will be having center of gravity. So we want to calculate the moment of inertia of a uniform rod. So first we have to consider the length of the two sides of the rods, that is L by 2 and L by 2. And one side it will be taken as negative and another one side it will be taking the positive. And then we first calculate di value. Di is nothing but dm into x square because small mass only we had considered. So a small mass it will be mentioned with the dm. So di is equal to dm into x square. So dm we want to calculate. Dm is nothing but at a small distance as having linear mass density. So lambda into dx. That the lambda it will be mentioned with mass per unit length. So m by L into dx. Then substitute the dm value and x square value. So I is equal to integral of di is equal to m by L into dx into x square. And m by L it will be taking the outside minus L by 2 plus L by 2 x square into dx. Okay. So m by L it will be taking the outside and x square integrating x square is x cube by 3. So x cube by 3 L by minus L by 2 plus L by 2. So m by L x cube by 3 L by 2 the whole cube by 3 minus L by 2 the whole cube by 3. So m by L cube by 8 by 3 minus L cube by 8 into 3 by 3. So this minus plus, so L cube by 24 plus L cube by 24, 2 times is there. So 2 L cube by 24. 1 2s are 2, 12 2s are 24 and m by L cancel. So m L square by 12. So 1 by 12 into m L square. So this is the moment of inertia of a uniform rod. Now we want to calculate moment of inertia of the uniform ring. Taking one ring. Okay, this is the ring. This is the ring. In the center part is a empty space is there. This is the ring. Okay. We had considered the one single point. That's a side that it will be only we had considered. That's a side it will be mentioned having some mass. That the mass it will be mentioned. This is only we had to consider. This side is having the mass is dm. Okay, this only we had considered. That's a mass and we are having dm. And the circuit will be having some radius that is capital R. that's the distance, it will be called as dx. Okay, so now we want to calculate di value. So di is equal to dm into r square, because dm is an infinitely small mass and the radius is capital R. So di is equal to dm into capital R square. So dm is equal to, already I told that in the previous one, dm is equal to lambda into dx, because linear mass density, the product of linear mass density in the distance. So lambda into dx, and then we want to calculate I is equal to integral of di is equal to, substitute the di value is dm into r square. Dm is, we want to calculate lambda value. Already I told that lambda is linear mass density. So linear mass density is nothing but mass per unit length. So m by L, but unit length is the uniform ring. So that the ring, it will be creating the circle. So we substitute the length instead of circumference of the circle. Circumference of the circle is 2 pi r. So m by 2 pi r. So now we substitute that m by 2 pi r value instead of lambda. So m by 2 pi r into dx into r square. Okay. So limit is 0 to 2 pi r. So m, it will be taken as outside. So m r by 2 pi integrating 0 to 2 pi r into dx. Okay, integrating 0 to 2 pi r into dx. So now we substitute that rm by 2 pi integral of 2 pi r into dx. Now we want to calculate integral of dx. So m r by 2 pi. So integrating of dx is x and applying the limit 0 to 2 pi r. Okay, so m r by 2 pi, and then applying the upper limit is 2 pi r, applying the lower limit is 0. So substitute 2 pi, it will be cancelled, r, that is m r square. This is the moment of inertia of a uniform ring. A ring, we are considered as one ring, that the ring will be having a mass, we are considered only one simple mass, and then it will be having we are considered a little bit mass in the ring. Okay, chinna portion la mass amata consider panikirom, that the distance is dx, and then radius of the circle by making the ring, that it will be called as capital R. So now we want to calculate. So dm is equal to lambda into dx, and then I is equal to integrating of di is equal to 0 to 2 pi r m by 2 pi r into dx into r square. Then substitute that lambda is equal to m by L, and then L, we want to substitute the circumference of the this circle, that is the circumference of the circle is 2 pi r. So substitute the lambda value in this part and the dm value in this part. So dm is equal to m by 2 pi r into dx, and then substitute the dm value in this. So m by 2 pi r into dx into r square. Okay, and then r cancel. So rm by m r by 2 pi integral of 0 to 2 pi r into dx. So m r by 2 pi, and then integral of dx is equal to x. So x 0 to 2 pi r. So m r by 2 pi, applying the upper limit minus lower limit, 2 pi r minus 0. So 2 pi cancel. So m r square. This is the moment of inertia of a uniform ring. Okay. So now we want to calculate the moment of inertia of a uniform disc. So first uniform rod, and then uniform ring, next uniform disc. Okay, how will you calculate? First taking the uniform disc. Disc is nothing but not a hollow space, is in the middle part. Only we had considered as one plate, like it will be considered as a one plate. Okay, that's a uniform disc. So uniform disc is having the radius r. We had considered as the two circles in the uniform disc. Disc will be having the outer layer and the inner layer. The outer layer radius is capital R and inner layer radius is small r. Okay. Now we want to calculate the moment of inertia of the uniform disc. So first, already I told that di value we want to calculate. So di is equal to again dm into r square. We want to calculate dm, but this is a uniform disc, so it will be occupying some area. So we want to calculate linear mass densities now. We want to calculate surface mass density. So surface mass ingela linear ah irukudhu. This is the length of the one rod. This is the length of the wire. It will be joined to make a ring. But this knot, it will be having a ring. It will be occupying some space. So surface mass density only we want to calculate. So surface mass density sigma is equal to capital M by A. So surface mass density is equal to mass per unit area. Mass per unit area of the circle, just like a circle. One plate it will be having the circle form, that the plate area is pi r square. So M by pi r square. Okay. Then this is the linear mass density. Now we want to calculate the dm value. Dm value we want to calculate. Dm is equal to, okay, dm is equal to sigma. Sigma is surface mass density and then circumference of the disk. Circumference of the disk, because it will be occupying some area. So we surface mass density we want to calculate, substitute the area, but the total dm value we want to calculate, because the dm value it will be considered in the outside only. Dm value will be considered as the outside only. So we want to calculate circumference also. So sigma into 2 pi r into dr. Okay. So we want to substitute the sigma value. Sigma value is m by pi r square. M by pi r square 2 pi r into dr. Okay. So this part it will be having area of the circles also and circumference of the circle also. Area of the circle is only, it will be with the surface mass density is equal to mass per unit area. So m by pi r square. Then dm is equal to sigma into 2 pi r into dr. So 2 pi r into the 2 pi r sigma, we want to substitute the sigma value, that is m by pi r square. So m by pi r square into 2 pi r into dr. So we can substitute the common terms. Pi, okay, 2 pi r into dr. So 2m by r square into r square. Then dm value we have to put, and then another one r square is there. So di is equal to 2m by r square into r square into r into r square. So r into r square into dr. Okay. Because the dm value it will be substituted in this equation. So dm is equal to sigma into 2 pi r into dr. So m by pi r square into 2 pi r into dr. This term it will be substituted in this term. So m by pi r square 2 pi r square into dr. So 2m by r square into r square is there. So r is there. So r square into dr. So r square into r into r, that is r cube. So 2m by r square into r cube into dr. Okay. Then now we want to calculate the moment of inertial term. Integrating 0 to r into 2m by r square into r cube into dr. Now integrating this equation. So how to integrate ma? Say m is equal to 2m by r square. So 2m by r square it will be taking the outside. 2m by r square it will be taking at the outside, and then integral of 0 to r cube into dr. Okay. Already I told that integral of x square into dx. Integral of x cube into dx. So x cube into dx, already I told that x power n plus 1. So 3 plus 1 by 3 plus 1. This is the formula, because x power n plus n into dx is equal to x power n plus 1 by n plus 1. So x power 3 is equal to x power 3 plus 1 by 3 plus 1 is x power 4 by 4. So x power 4 by 4, that is r cube is r power 4 by 4. So substitute that value. So I is equal to 2 pi by r square, 2m by r square, and then integral of r cube is r power 4 and limit is 0 to r. Then I is equal to 2 pi m by r square, then r power 4 minus 0. So r power 4 means r square cancel. So 2m by r, this is the r square term. So this is r square, this term also r square. So 1 by 2 mr square, this is the common term for 1 by 2 mr square. So how will you calculate the 1 by 2? R power 4 by 4, r power 4 by 4. So r square is there, r power 4 by 4, so capital R power 4 by 4 minus 0. Okay. So 2 and then 2 cancel, r square r cancel. So m r square by 2. So 1 by 2 mr square. This is the moment of inertia of a uniform disk. I is equal to mr square. So this is the uniform rod and uniform ring and uniform disk. So the moment of inertia of the rod, ring, disk easily calculated. And then suppose this all are the common shape of the body. Moment of inertia easily expressed in the shape of any one object. But suppose we have to consider as a one irregular object, not a definite shape object. So we have to calculate the. We can easily calculate the moment of inertia of suppose one body is having the irregular shape, not a perfect shape. Moment of inertia formula for ring, disc and a rod and various spheres and hollow cylinder, that all are as have in the physics. But suppose we have to consider the irregular shape. How will you calculate? So first we have to consider the irregular shape of an object, not in a perfect shape, that the object is having number of tiny particles, that the particles is having some distance also, that's a particle, it will be considered as mi. So number of the particles, it will be mentioned with m1, m2, m3 and m4. So we will easily calculate the moment of inertia of irregular shape of an object, that the irregular shape of an object it will be mentioned by using the radius of gyration, that it will be mentioned with the term is radius of gyration. How will you calculate the radius of gyration? Radius of gyration is nothing but, suppose we want to calculate the moment of inertia of the irregular object, that the object will be having lot amount of molecules, lot amount of particles, that is m1, m2, m3, it will be considered m1, m2, m3, it will be considered as mn. So the moment of inertia I is equal to summation of mi ri square. Okay, mi ri square. Mi ri square is nothing but m1 summation means I is equal to m1 r1 square. I it will be mentioned with 1, 2, 3, 4. So m1 r1 square, m2 r2 square plus m3 r3 square and up to that mn rn square. Okay, this is the moment of inertia of all the particles in the non-rigid bodies or non-irregular shaped body. So taking m1, m2, m3, m4, it will be taken as m. Suppose we have considered all the particles will be having the same mass. So same mass means taking m at the outside and then it will be mentioned with r1 square plus r2 square plus r3 square up to that Rn. So the particle, all the particles are having the equal mass. So that the particle will be mentioned with small n. So mass of all the particles into r1 square plus r2 square plus r3 square up to that Rn square. So the nm it will be mentioned with capital M. Capital M is equal to r1 square plus r2 square plus r3 square plus up to that Rn square. So this is the radius of all the particles in the rigid body. Okay, now we want to calculate the, now this term it will be mentioned with k. This term it will be mentioned with k. So I is equal to m into k square. This is the k value, it will be mentioned with r1 square plus r2 square plus r3 square up to that Rn. Okay, r1 square, r2 square and then Rn square, it will be mentioned with k square. So k it will be equal to k value it will be mentioned with radius of gyration. So radius of gyration it will be equal to n and m, it will be mentioned with n value, it will be multiplied because number of the mass. So on the same time it will be divide that. N we want to multiply, on the time we can divide also. So we must divide also. So the nm it will be taken as capital M and r1 square plus r2 square plus r3 square up to that Rn square by n. That the value it will be mentioned with k square. So k square is equal to r1 square plus r2 square plus up to that Rn square by n. So k is equal to square root of r1 square plus r2 square plus up to that rn square by n. That the k term it will be denoted as radius of gyration. Radius of gyration it will be used to find out the moment of inertia of the irregular shape of an object. This is the moment of inertia of an irregular shape of, not a particular shape of an object. So the k it will be mentioned with the radius of gyration. Radius of gyration is an important 2 mark. Radius of gyration it will be also termed as square root of the squares of the radius of the all the particles in a rigid body. So that will be called as radius of gyration. So radius of gyration k square is equal to r square r1 square plus r2 square plus up to that rn square by n. And then k is equal to square root of rn square plus r2 square up to that rn square by n. This is the root mean square radius r radius of gyration. Okay. So radius of gyration it will be used to find out the moment of inertia of a particular not a particular object, not a undefined object. Okay. So not a, it will be used to find out the moment of inertia of a undefined object, not a irregular object, not a regular object. It will be used to calculate the moment of inertia of the irregular object. Okay. So this is the way we easily calculate the moment of inertia of a. First you should know about the what is the moment of inertia. Moment of inertia is nothing but inertia of inertia means as a mass of one object in the translation motion. In the rotation motion, mass of one object it will be denoted as moment of inertia. So moment of inertia unit is kilogram meter square and the dimension formula is ml square. And moment of inertia easily is calculated in uniform rod and uniform ring and uniform disc. First we should know that first we taking the uniform rod, it will be considered as a small mass, then consider as the linear mass density, substitute the linear mass density in the formula and then easily calculate the moment of inertia value. So the moment of inertia value is equal to 1 by 12 ml square for the uniform rod. Okay, but uniform moment of inertia of the uniform ring is taking one ring, that the ring it will be having some mass, that the mass is dm and the radius is capital R. So easily is calculate the di value, substituting the lambda value is m by l is m by 2 pi r, substitute the m by 2 pi r value and then taking the integral of dx and 0 to 2 pi r. So rm by 2 pi, so mr by 2 pi integral of x and d 0 to 2 pi r, substitute the limit value and mr by 2 pi r minus 0. So I is equal to mr square. This is the moment of inertia of the uniform ring. This is the same way we easily calculate the moment of inertia of the uniform disc. But uniform disc is having the area. So linear surface mass density we can use instead of linear mass density. So surface mass density is sigma. Sigma is nothing but mass per unit area. So mass per unit area we want to substitute. So dm is equal to sigma into 2 pi r into dr. Then linear mass density is mass per unit area. So m by mr square, pi cancel and 2 pi m by r, substitute the dm value in this equation and 2m by r square into r into dr. Then di is equal to 2m by r square r cube into dr. And then I is equal to integral of 0 to r 2m by r square into r cube into dr. So 2m by r square integral of r cube into dr. So integral of r cube is equal to r power 4 by 4. Substitute the upper limit, substitute the lower limit and easily calculate I is equal to 1 by 2 mr square. This is the same way we easily calculate the moment of inertia of the irregular shape by using the radius of gyration. So first we can choose the mass of the particle. Moment of inertia is equal to summation of mi r square. So this is the formula for moment of inertia of the all the particles will be lying in a irregular shape object. So summation mi ri square. So m1 r1 square plus m2 r2 square, m3 r3 square plus up to that mn rn square. Divide and multiplying by small m because number of molecules we want to mention. So nm into r1 square plus r2 square plus r3 square up to that rn by n. Then taking nm is capital M. So capital M into r1 square plus r2 square plus r3 square up to that rn square by n. This value it will be considered as capital K square. So K square is equal to this value and K is equal to square root of r1 square plus r2 square plus up to that rn square by small m. This is the radius of gyration. Radius of gyration, it will be used in used to calculate the moment of inertia of the irregular object. Okay, so in the today's session I explained what is the moment of inertia, how to calculate the moment of inertia of a uniform rod, and moment of inertia of the ring, and moment of inertia of the uniform disc, and then how to calculate the moment of inertia of the irregular shape of an object. Okay, home assignment for today's session: learn and write moment of inertia of uniform rod, a ring and disc. Okay, students, note down what is the homework mark. Learn and write moment of inertia of uniform rod, ring and disc. Okay, thank you.